Hello. Hello, good evening.
Hi.
This is Arpan. Today I will take your demo session. Okay, let's start. So first of all, we are going to discuss, the topic name is function. Okay. So it's basically, you will see that in IB analysis and approach analysis, this is the first chapter. So we'll discuss function. So can you tell me, like, how can we define a function? Like, no need to tell any bookish word, like you can just try to explain idea by giving one or two examples.
I think what I define a function is something that when you put in an input, it gives you an output. And for every input, there's like a unique output. So, yeah.
Okay.
And it has a well-defined range and domain.
Okay. Okay, fine. So more or less you are saying like it is basically compared to a water tank where like this pipe we can consider like inlet and this one is outlet. So if we compare with this, now you can see that, like as you said, we can give input like 1, 2, 3. So output, there would be certain output. It is look like f of 1, f of 2, f of 3, isn't it?
Yeah.
Now question is, let it name this one by f. Now question is, you can see that like f of 1, f of 2, f of 3. Now you said one more thing, like it has an unique output. So unique means like f of 1, what would be its value? Can you consider 2?
Okay.
And f of 2, can it be considered as 2 as well?
No.
Okay, it's not. What about f of 3? We can't consider 2?
Actually, technically, this is, no, I don't. Every input has a unique output, but then technically one output can have many inputs, right?
Okay, I got your point. So I will try to tell you one more thing, one more diagram. With the help of that, I believe like concept would be clear. So idea of input output is very fine. Now we are a little bit confused about whether it will have unique output or not. So to avoid this, like to clear this conception, let me draw one more figure. Like these are two circles. You know the circles, like let's say this is A and this is B. This one is domain. Have you heard this word? Domain?
Yeah.
What's that?
The x inputs.
True. So the all possible values, like x values, like if we consider all possible inputs in a set, so that would be domain. And what about B?
The range.
Yeah. How can you define, like what is range?
All your y values.
Okay, that's perfect. So it means all possible outputs would be here. So it means y values, collection of all y values, true, of functional values. Now question is, for this to say, there should be a linker. Linker, it is linked by, let's say, f. So this is basically a function. Now question is, if we consider inputs as name of certain person, name of any person, like it can be like you and there and B and C are your friends. So you can see that like all these are inputs, and if carries all the inputs or assigns all the inputs to outputs. Now question is, if I ask you, what about B? How can we define? So birthday of the respective person. Like suppose if I ask you, about your birthday. Which day is it?
20 July.
Okay. Now question is July 20th. July 20 if we write. Now question is, can you see that like one of your friends like B, is it possible to have the same birthday?
Yeah.
And what about C?
It's also possible.
So it means function holds the same thing, like different x values or different inputs can have same output. It's possible.
Okay.
So many to one, it's possible. So this is the first concept we need to know. Apart from this, one sec, let me draw another. So we'll consider domain as same, name of person, and B would be, range would be basically their birthdays. Now if I say like birthday of A is on July 20, at the same time I am saying September 20, is it possible?
No.
So it means one to many, like one input can have more than one output. It is not possible for a function.
Yeah.
Okay. And interestingly, one more thing, like function, like suppose there are 10%, function is bound to take each or bound to carry each and every x values to y values. So it's not like that function can take only 10 out of 10, like function can consider only 7 or 8 out of 10. It's not like that. Whatever be the elements here or whatever be the points here, so function has to consider or has to carry this to different y values or maybe same y values. It depends on the nature of the function.
Okay.
Now question is, how are we supposed to, like, can you give me one or two examples of a function?
F of x is x squared plus 3.
Okay. X square we can consider. After that, it's not like that we have to always consider f of x. We may consider g of x, like x cube minus 2. Now at the same time, if I tell you f of x equals to modulus of x, have you heard about modulus function?
Yeah, it's like the absolute value of x.
Yeah, absolute value. Yeah. So can we consider this one as a function?
Yeah.
Okay. And what about this one? F of x equals to, let's say, this. Can we consider this one as a function?
Yeah.
Okay. So for a function, we'll discuss this one. How can we, from the graph, how can we have the function? Like, let me draw a few graphs. First one is a circle. The next one, it's an ellipse. After that, we can have a vertical line. After that, we can have a horizontal line. After that, we can have parabola like this. After that, now question is, there are 6 figures, 6 graphs. So which one of these would be function? Like there can be more than one correct answer. It's not like that only one would be correct.
The horizontal line and the down parabola.
Okay. So how did you get this one? Suppose this is 1, this is 2, this is 3, this is 4, this is 5, this is 6.
Yeah.
So you said probably 4th one and 6th one.
6.
Yeah. Why not others?
Because if you were to do the straight line test, they would intersect at many points in the graph.
So basically it's not like straight line test. Straight line has to be a fixed line. Fixed line means it has to be a fixed type. It's called vertical line test.
Okay.
Means the straight line has to be a vertical line. It can't be slant. So vertical line test, it says like if we try to draw any vertical line so that it intersects. So you can see that like if it has more than one point of intersection, like this one, we have already done 2, in fact 3. Y-axis if we consider, you can see that for a single line it intersects 2 points. So this is discarded. For ellipse, it would be the same thing. And what about 3?
Because one value of it seems if you were to draw a vertical line on that line itself, wouldn't it intersect different points?
Okay. So you meant to say like if we try to draw any vertical line, so like we can draw a vertical line in that manner. Let's say this one. So as if like they will coincide. So it means there are more than one point of intersection. That's what you mean to say? Like infinitely many point of intersection.
Yeah.
Okay. So more than one point of intersection, it's not a function.
Okay.
Okay. Now question is, if we move to the 4th one. The 4th one, it's basically, you can see that like if we draw only for a single line, we will get only one point of intersection. And here for 5th one, you will have more than one point of intersection. So that's why. So it's called vertical line test. After that, we have to discuss domain. How can we have domain and how can we have range? So for that, like if I ask you, what can be the domain of this function?
X has to be more than or equal to 7.
Okay, how did you get this?
Because if it was a number less than 7, for example, like 6, it will give you a negative number inside the square root, and that would make the function undefined.
So actually you can have negative number under the square root. It refers to complex root. Okay. So this is not possible in terms of real numbers. So for that, x minus 7 has to be either greater than 0 or equal to 0, which refers to x would be greater than equal to 7. So this is domain. Now question is, can it be expressed in set form or interval form? How can we express this?
I don't know.
Okay. So first of all, let me draw the line. So basically, if we try to use number line, if we consider 7, so you can see that like when 7 is included, it means either x is greater than 7 or equal to 7. So first of all, we have to draw a circle. If x is greater than 7, so circle would be hollow, like you can see that like whatever we have done, we have drawn. And when it is equality sign is there, so this is a darken, like we have to darken it. So when it is greater, it means it should be towards the right. Right means towards the positive infinity. So you can see that like this would be the number line representation, and in interval notation x is greater than 7 means we have to use square bracket 7 infinity. And when x is greater than 7, let me show you. So here is 7 and it should be towards right. And how are we supposed to denote it? This is 7 and this is infinity. So this is open.
What is the reason for using the curved bracket for the infinity side?
It's basically,
why don't you use the square bracket?
It's basically notation. Notation means like basically it refers to that end points are excluded.
Okay.
Like 7, if we start our journey from 7, it means 7 is not included. And infinity, since it is not finite, always remember, it is not possible to use square bracket. So that's why always like this is, it means end point is excluded. It can be either this or this, always. Now this means end point is included. Okay, let's come to one more example. Here we can consider f of x equals to square root of x square minus 9. So how are we supposed to find the domain?
X cannot be -3 or 3.
X cannot be. I didn't get this one.
It can be more than, as in, I don't know how to say this. Technically, it can be any number, right? I'm not sure. I think it can be any number.
I think you are on the right track. Whatever you are saying, it's fine. I can see that why I said this, because I can see that you have the basic idea when it is defined, like whenever any expression under the square root, when it is defined. So if we think like this, you rightly said x square minus 9, that would be greater than or equal to 0. That's true. Now question is, how can we find the answer? Like we are not supposed to say that x square would be greater than 9 or equal to 9. It's not the ideal way to represent domain. Domain means possible values of x, not possible values of x square. So that's why we have to convert it in terms of x. So can we factorize this one?
X plus 3, x minus 3.
Perfect. So x plus 3 times x minus 3 greater than equal to 0. So there are two ways to find the answer. Like if you remember, let me discuss a rule. So if you are able to remember this rule, so I believe finding answer would be easier to you. So x minus x1 times x minus x2 greater equal to 0 with a property, with a condition x1 is less than x2. It means x minus x1 times x minus x2, that is greater equal to 0 with x1 less than x2. Does it make sense?
And what does this give you? Because I'm a bit confused.
No, I'm just saying the condition, because can you see that like this rule we can compare with this. So that's why I'm just saying this rule. So what does it imply? X should be greater or equal to the greater value. Which one is greater? x2. Or x should be less or equal to the smaller one, which is x1.
Okay.
Now, using line diagram, suppose x1 is here and x2 is here. So for x2, we have to go like this. It's filled. For x1, we have to go like this. So you can see that like this two, like we are excluding the middle value. Apart from this, the domain would be like this.
Okay.
And now this is the first approach, first way to find out. Second way is to use line diagram. First plot x1 and x2 on this number line. Then if you try to use any random value, you can see that once we plot x1 and x2, there are three regions. To the left of x1, one region. To the in between x1 and x2, another region. And to the right of x2, another region. So if we use any random value to check whether it satisfies, like if we substitute this here to check whether it satisfies this condition greater or equal to 0. So it means this value matches and we have to consider that. We'll explain with the help of this. Let's come to this one, any numerical value. Can you apply the first rule to get the answer?
Yeah, so x1 is 3 and then x2 is negative 3. Is it because x1 is negative 3 and x2 is 3?
Okay, it's not like that. Like whatever, like first we have to identify the two values of x. So if we set each factor to 0, what are the values of x?
Negative 3 and 3.
Which one is smaller? Which one is greater?
Negative 3 is smaller.
So what should we write?
X1 is negative 3 and then x2 is
x would be less than the smaller value when it is greater equal to. So less equals to negative 3, or x is greater equal to the greater value, which is 3. So that's what we are supposed to write.
Okay.
Now question is, like if this approach, like from this, you can see that on interval notation, we can write when it is negative infinity and negative 3. Negative 3 is included, or x belongs to 3 to positive infinity.
Okay.
Now second approach, like second method, first we have to draw the number line. And here we have to plot 2 points, negative 3 and 3. Can you take any random value to the right of 3?
4.
Okay, if you substitute 4 here,
you get 5. Oh, there?
Yes, on the original expression.
Yeah, okay, so you get 4 square minus 1, so 7.
So which is positive?
Positive 7.
So it's greater or equal to 0. So you are getting positive, right? So it is called sign diagram. And in between any value, negative 3 and 3?
0.
Okay, if we consider 0, so can you substitute over here?
You'll get negative 9.
So it's positive or negative?
Negative.
So we can substitute negative. To the left of negative 3?
Negative 4.
Okay, let's substitute over there.
You'll still get positive 7.
So it means, like to the right of 3, you are getting positive. To the left of negative 3, you are getting positive. In between negative. So you can see that it's only positive or equal to 0. So negative value, it's not possible. And where it is, like once you substitute 3, it is 0. Once you substitute negative 3, it is 0. So don't you think the domain would be this, using sign diagram?
Yeah.
Okay. So now we'll try one more thing. G of x equals to this. You have to get the domain.
Okay. So it's either less than -4 or more, less than or equal to -4 or more than or equal to 4.
So it says like 16 minus x squared, that would be greater or equal to 0. So
Yeah.
if we try to multiply it by negative each side, so it would become x minus 16 less equals to 0.
Okay.
Isn't it?
Yeah.
So x minus 4 times x plus 4. So what would be the domain?
X is more than -4 and less than 4, but equal to both of them.
So when it is less than equal to, in case of greater equal to, just or greater than, we have discussed the rule. X should be greater than greater value or greater equal to greater value. X should be less than equal to the smaller value or less or equal to the smaller value. So, but here the sign is less equal to. So don't you think x should be in between these two?
Okay. Yeah.
So that would be the domain. Now question is, using the line diagram, how can we have this? Once we get -4 and 4. To the right of 4, what would be the number?
Like 16 minus, for example, 5 squared. So 16 minus 25. So negative.
But here it's positive.
Negative.
So it's negative. In between any two value.
So 0. So you'll get 4. Positive 4. If you get x to be 0, it will be positive 4. And then the other side, if you did like -5, you'll also get -9.
Yes, true. True. But thing is that, like, you can see, like positive, negative, all those sign we have got. Now where equality lies?
In between -4 and 4.
No, equality means when these result would be equal to 0. Here -4 and 4. So that's why we have to consider this.
Okay.
Now question is, can you write it in the form of intervals?
It would just be x is part of a open square bracket -4, comma 4 close square bracket.
Perfect. So we should use square bracket for this, because all these are included. X belongs to -4, comma 4 square bracket. Okay. So after that, we need to discuss one more thing. It's basically f of x, let's say 2x plus 7. Find f inverse x. How can we have inverse of this?
So what I used to do is let f of x is equal to by. Then you do y is equal to 2x plus 7.
Okay.
And then move the 7, will be y minus 7 is equal to 2x. And divide everything by 2. So you get x is equal to y minus 7 over 2. So f of inverse of x is x minus 7 over 2.
Perfect. You rightly said first step is to convert f of x in terms of y, and then we have to change the subject, like we have to make x as the subject. So for this, we have to divide each side by 2 So it is y minus 7 over 2. And this is f inverse y. The right hand expression is in terms of y, that's why. So f inverse x, this is x minus 7 over 2. Now question is, if we try to find what would be the range, how can we have the range?
I mean, it can be any number, right? Technically.
It can be any number. Why do you think so?
Because x can be any number, and if we were to put any infinity, for example, a number, we will still get a valid output.
Yeah, true. So it means like, first of all, we can say any number is possible as there is no square root. There is nothing in the denominator, only a numerical value is there. So there won't be any point of discontinuity, or what should I say, like for any value of x, it won't be undefined. So any real number, you rightly said, but how are we supposed to express this?
Y, or like f of inverse x, it belongs to any real number, like the r.
The range would be any real number r, true. Or in interval notation, how can we represent this?
Like negative infinity to infinity in like curve brackets.
Yes, true. That's perfect. Now question is, if we try to use composition of function, are you familiar with composition?
Yeah.
So that's also important. For composition of function, if we try to use, like, composition of function is generally defined by this. And we have to, first of all, it is not equals to this. This is composition. And this is product. These are completely different. Okay. Now, how will you define composition? If you see that left one f, right one g. So the right one would be the inner function, right? And it is not necessarily equal to g of f of x, which is equals to this. So now question is, if we move to the previous question, f of x equals to 2x plus 7, and let's say g of x equals to x square. So can we have f of g of x and g of f of minus 1?
Yeah, so f of g of x would be 2x squared plus 7.
Okay.
G of f of negative 1 would be negative 2 plus 75, 25.
So it is 2x square plus 7, true. And g of f of negative 1, this is basically g of 5. So it is 5 square, 25. True. If we substitute negative 1 here, so you will get 5. You will get 9. So definitely you can see that the right hand and left hand completely different. Now my question to you, for the same function, what would be its value? F of f inverse x and f inverse f of 4. If you want, you can scroll up to see the inverse function, which you have already got.
Isn't the f of f inverse going to give you x.
Okay.
Isn't that like a rule or something?
Okay. Why do you think so?
No, I was just asking if it's a rule or something.
Yeah,
It's
it
like
might
if you
be.
do, or is it
It might be. It might be. But we can't assume anything. Like we have to show this. Like why it would be like if it is like you were saying the composing any function with its inverse, it will lead to only x. So we have to prove this. How can it be possible? Or at least graphically we have to, or using the diagram we have to show that.
so f of inverse is 2. Yeah, because if you say f of f inverse, if you put x minus 7 over 2 into 2x plus 7, and you like substitute it for the x, you get 2 times x minus 7 over 2. You cancel out the 2's because when you multiply them, so it's x minus 7 plus 7, which gives you x.
Yes. So first of all, why? Let me just discuss one more thing, so that we can have the idea. So first, like when we are composing any function, so like first, if x is going to f of x. Now the same f of x is coming to x when we combine, like you can see that this is going in that direction with the help of f. Now it is f of inverse. So if you compose, means you are returning to the same point. So that's why logically it should be x, true. So it doesn't matter whether you are composing to the right or left, that should be x. What about this one?
It would Six, 8, 15. It's going to give you 4.
True. Okay. So one more thing I would like to discuss. Suppose there are a few values, 1, 2. This is number A. 2, 1. 5, 2. 4, 1. And 0, 1. 4, 1. 5, 1. 7, 1. This is B. And this one is D. So which of these, like there are, like you can see that this one represents like these ordered pair. Can it be a function like A, B, C, D?
A and B can be functions, but not C and D.
Okay. So if it is so, can you tell me the reason why A and B can be functions?
It's because for every, for example, value of x, you get a different value of, you get a unique y value, and there's no two of the same x values that give you a different y value. And the same thing applies for B. Although they all have the same outputs, their inputs are different. But if you look at C and D, for example, C, the input is -1. It's the same input, but you're getting different outputs, 2, 4, 5, 6. And the same thing with D, if you take, there are 2 5s, which give you -4 and 0. So they're not functions.
True. Fine. So let's come to now conceptual discussion we have made. Now we'll discuss a few questions. Okay. So some questions might not be might not be covered in the first 30 or 40 minutes. So we can discuss this one. So let's start from question number 1. It says f of x is equals to 7 minus 2x and g of x equals to x plus 3. We have to find g compose f of x. Let's find it out.
So g of f of x. So you put the 7 minus 2x into the x plus 3. So you get 7 minus 2x plus 3. So that's 10 minus 2x.
Okay, you got 10 minus 2x. So this is going to be, just a sec, let me check this question. So yes, now we can write g of f of x. This is g of 7 minus 2x. After that, in place of x, we should write 7 minus 2x. So this is going to be minus 2x plus 10. Isn't it?
Yeah.
Okay. What about the next one?
It would be x minus 3.
Okay, how did you get this?
So, like, you let g of x to be y. So you say y is equal to x plus 3. Move the 3, it becomes negative 3. So you get x equals to y minus 3. So f inverse of y equals y minus 3. So g inverse of y is y minus 3. So g inverse of x is x minus 3.
Yeah, perfect. So what about 3?
5 minus 3 is 2. So 2x is 4. So it's 3. Your answer would be 3.
I believe like f of g inverse of x. So you got g inverse, right? So
Yeah.
g inverse of 5, what would be its value?
2.
Okay. So f of 2 is 3. Yes, it's fine. So let's come to question number 2. Consider f of x equals to 2k x square minus 4k x plus 1 for k not equals to 0. The equation f of x equals to 0 has two equal roots. You have to get the value of k.
Would you use the discriminant formula?
Okay.
That 4k, so like negative 4k squared minus 4 times 2k times 1 is more than 0.
Okay.
So then you get 16k squared. 16k squared minus 8k is more than 0. So 2k squared minus k is more than 0. Then you'll get k times 2k minus 1 is more than 0. So it's either k is more than 0 or 2k minus 1 is more than 0. Or something like that, I think.
Okay. So let's check. First of all, I believe we can discuss a bit about quadratic equation. So quadratic equation, it's basically the standard form. Any quadratic equation, it's f of x equals to ax square plus bx plus c, where a can't be equal to 0 because a is the coefficient of x square and a is called leading coefficient. If leading coefficient becomes 0, it means it will become a linear equation. So that's why a can't be equal to 0. Now plus c, this indicates y-intercept. Y-intercept means if we try to draw any quadratic equation, so it would be a parabola. So y-intercept means this one, the point where it meets the or intersect y-axis. If it is above, see, the value of c would be positive. If it is above the origin, then it would be positive. If it is below the origin, then it would be negative. Now question is, as you said, discriminant. Discriminant is, it's basically a tool. For how can we have discriminant? First of all, we have to know using quadratic formula. If we use quadratic formula, we will see that x should be, the value of x should be minus b plus or minus b square minus 4ac over 2a. Now, as you know, any term on the square root cannot be negative. So this one, it's denoted by delta. This is called discriminant. When delta is greater than 0, so the graph, especially quadratic, represents a parabola. Quadratic equation represents a parabola. When delta greater than 0, so roots are real and distinct. It means x-intercept are different. There would be two different x-intercept. These are roots or zeros. Root means x values when a is greater than 0. Always remember, when a is greater than 0, like a is greater than 0, implies the parabola is open up or concave up. A means leading coefficient. When a is negative, it implies it is concave down. So the same thing, when discriminant is greater than 0, when the value of a is negative, so one of the graph can be like this. So here for these 2 points, x values are different. So these are zeros and here a is negative. Now question is, when discriminant is 0, so roots are real and equal. Okay. Now question is, why it is so? Because you can see that negative b plus or minus, if you get something positive, only then root will differ. If you substitute the whole part equals to 0, so only minus b plus over 2a, that would be your answer. It repeats twice. So that's why equal roots. So for equal roots, the graph would be like, it will definitely touch x-axis, but it would be tangent. Let's say
discriminant is 0, your solution would be your turning point?
Yes, turning point means vertex. Okay. Now question is, when it would be like this, when a is greater than 0. And when a is less than 0, especially always remember the turning point when discriminant is 0, the turning point, at turning point, x-axis would be its tangent. So this is less than 0.
Okay.
Now question is, what do you think? How can we draw when discriminant is greater, less than 0?
It just doesn't ever touch the x-axis.
Okay. True. So first of all, it might touch y-axis, but it won't touch x-axis, because x-axis, if it touches x-axis, it means it has real roots. So when a is greater than 0, it would be like this, and when a is less than 0, it would be like this. And apart from this, we have discussed quadratic formula. You know, there is one more method, completing square method. Using that, we can also express this one in that form. Instead of that, a times x minus h whole square plus k. So then h comma k will be the turning point or the vertex. Okay, so now let's move to the question. Here it says f of x is this, where k is not equal to 0, and f of x equals to 0 has two equal roots. Find the value of k. How can we have the answer?
So because it has two equal roots, you have to, the discriminant will be more than 0.
Is it two equal roots? It says. Will it be more than 0?
No, it is equal to 0.
Yes. So first we need to get the discriminant. What would be the value of discriminant?
0.
No. What I meant to say, how will you find discriminant using this equation? Then we will set to it 0.
It will be the negative 4k squared.
That is 16k squared.
Yeah. And then minus 4 times 2k times 1, which is 8k.
Okay. If we set
question.
Yeah.
How would you have two equal roots? Wouldn't it only be one root because it only like touches the x-axis once?
Yeah. As I said, like tangent, it's a tangent. Tangent means equal roots. Like, you know, for that, if we have one example like this, suppose if we are asked to solve this. So is it quadratic or not?
Yeah, it is.
So if we use this method, can we get this one or not?
Yeah.
So x minus 2 whole square is x minus 2 times x minus 2 equals to 0.
Okay.
So if we set it to 0 or this, so x minus 2 will be this or this.
And they're equal. Okay.
Now question is whether discriminant would be 0. Can you check once? B square minus 4ac.
Of this equation?
Yes.
Would be 16 minus 16. Yeah, it equals to 0.
So that's why. Does it make sense?
Yeah. Makes sense.
Okay, let's move to the question now. So we got 16k square minus 8k equals to 0. So let's solve for k.
You can divide the whole thing by 8, so it simplifies. So you get 2k squared minus k is equal to 0.
So let's factor out 8k. So you will be left with 2k minus 1 equals to 0.
And so either 8k is equal to 0 or 2k minus 1 is equal to 0.
Okay.
But you have to reject 8k is equal to 0 because they told us k is not equal to 0.
Perfect.
2k minus 1 is 0. So 2k is equal to 1. So k is equal to half.
True. So this part is done. What about this part? The line y equals to p intersects the graph of f. Find all possible values of p.
So does it mean like p is equal to 2 times 2kx squared minus 4kx plus 1?
like you can see that like it refers to, basically it refers to a parabola, as I said. And now you can see that like they are saying y equals to p. Which type of line is this?
Vertical.
Yeah, vertical line. Is it vertical? Okay, let's check whether it is vertical or not. Just a sec. We can move to the next page. No, this page would be fine. So first of all, if we consider all those points where like you will get the same y values, like 2, 2, 3, 2, -4, 2. So if we try to plot all those points, so you will see that it's nothing but a horizontal line, because it's y equals to 2. And for vertical, x coordinate would be same.
Okay.
So now if we come to this question, okay, meanwhile you can check, moderator has sent you details, like all details sent for IB coaching program. You can find it in mail, and you like our team will call your parents tomorrow. Okay.
Noted. Thank you.
Okay. So what about this one? Now how are we supposed to get this?
So that means if y equals to p is a horizontal, you can't just let p equal to 2, like, because if f of x is that to a kx squared, technically does it not mean that p is equal to that formula? Or
first, don't you think like k is positive? It means leading coefficient is positive. The graph would be like this, like more or less like this, and you got equal roots for this value of k. Like if it is equal, so the graph would be roughly like this. Okay. Now thing is that like y equals to p, it intersect the graph, find all possible values of p. So if we somehow get the turning point, coordinate of the turning point, you can see that like below of this turning point of the vertex, if we try to draw any line, any horizontal line, it won't intersect the graph. But once we start to draw the horizontal line through the turning point, and if we go above, it will start intersect the graph.
Okay.
So what I meant to say, what would be the equation of that horizontal line which touches the turning point?
So the turning point would be negative b over 2a. That's the x value of the turning point. So that's 4 times half is 2. So negative 2. So it's 2 over 2. That's 1. Turning point is it 1?
Okay, you got 1. Okay.
That's the x value, and then the y value, just put it into the equation, so you get 2 times 1 squared, which is 2 minus, oh wait, no, never mind. It's 1 squared, which is 1 minus 2 plus 1. That is 1, that's 0 anyway, because it's on only one equal root.
So 1, 0 is the coordinate of the turning point, because it's on x-axis. Now, which line is this? Like, what would be the possible values of p then?
P has to be then more than or equal to 0.
Okay, so you meant to say p would be more than or equal to 0. True, because if we try to draw y equals to half, or y equals to 1, or y equals to 2, it should be above this, right? Isn't it?
Yeah.
So it means it will intersect the graph. So this is the way to find out this. So P would be greater or equal to 0. Okay. So Durga, do you have any question? Like,
No, I think it makes sense.
okay. Hope that's it for today. Hope you enjoyed the session. Thank you.
Thank you.
Bye.